Welcome. So here we're going to talk about how to solve a proportion. So we use ratios inside proportions. So a ratio is a relationship. Oops. This is a relationship between two objects, right? And when I have a proportion, I'm telling you that I have multiple ratios and that those ratios are equal. So a proportion is telling you that two ratios are equal to each other. So that's kind of how ratios fit into the proportion conversation. And when we're asked to solve a proportion, we're usually given something like this. I'll usually have something like 6 divided by x equals 15 divided by 10. Now, either side of this equal sign, those are both ratios. And I'm telling you that those two ratios are equal to each other. And so I've defined this relationship. So in order to do this, we actually use a little bit of algebra. So there's something called cross multiplying, which that may, kind of sound a little bit familiar, like it's something that maybe you've done before. I want to be very clear. You can only cross multiply when you have an equal sign that has two fractions on either side. So that's what we're really looking for. We're looking for something, that division sign on both sides, that fraction on both sides, and the equal sign in between. People sometimes cross multiply when they are not allowed to. There must be an equal sign, and you must have a fraction on both sides of the equation. So I'm going to cross multiply. What I mean is I multiply the x by the 15. So I'll write that as 15x. And then I multiply the 6 by the 10. And I get 60. So I'm doing this, and then I need to still solve for x. I need to isolate x, get it by itself. It's being multiplied by a 15. So I divide both sides by 15, and I end up with x equals 4. So if I'm asked to solve this proportion, I'm asking you to tell me what this unknown value is, and it happens to be 4. So 6 over 4 is the same ratio, just a different form. It is equal to 15 over 10. And that's what we're saying with this proportion. We're saying the ratio 6 over 4 is equal to the ratio 15 over 10. We also run into proportions that they're not so obvious. They don't just give that to you. Instead, it's a word problem. So let's do an example. Here I have an example of the pitch of a roof. And we are told, the problem statement says that the pitch of the roof is supposed to be 2 to 12. Now, when you're working with application problems, you're going to have to pay very close attention to the problem statement and or look in your textbook and see what information they give you, because a lot of these applications have very specific ways of doing things. For this example, for pitch, the first number is always the rise, which is the vertical height change, and the second number is the run. That is just the way they present these proportions. I could also have, not proportions, but ratios. I could also have written this ratio as 2 divided by 12, and that would be rise over run. So the question here, it tells me that the pitch of the roof is 2 to 12, and it tells me that the run is 20 feet, and it asks what is the rise. So this is kind of an implied proportion problem, right? They give me one ratio, and then they tell me some piece of information. So what I need to do is I need to have rise over run equals rise over run. But I need to be matchy-matchy. So this left-hand side, I'm going to have be the original ratio that I was given. So 2 divided by 12. And then the second component here, this right-hand side of the equation, I'm going to use the new information they gave me. They're asking me to find the rise. So whenever there's that question, I know that's going to be my variable. So I'll use X, although you could use any letter. And then they tell me that the run is 20 feet. So now that I have this, the hard part, I think, of these application problems is setting it up properly. And then solving it, we'll do the same process we did before. We will cross multiply. So we have 12x equals 40. And then we will divide by 12 on both sides. And we will end up with 40 divided by 12, I apologize. That's going to be 3.3 feet. So this should be our rise. The 3.3, you could also write that as a third. When I put it into my calculator, I get that repeating decimal. So the rise for this particular roof, for the roof that is 20 feet, should be 3.3 feet.